this is the third time today I teach this, so I've kind of figured out which ones I can skip so that we can go a little faster, okay? So if there's some slides I skip, that's why. All right, we need to know these definitions. We need to know the relationship between the radius and x and y values on this little triangle right here. X, y, and r, Pythagorean theorem, yes? Not anything new, yes? Okay, what I am concerned that you're sure you know is that y goes with sine and x goes with cosine. Do you know that? Alphabetical order, x before y, cosine before sine. Okay? And tangent, how are you going to remember that? Y over x. It is sine over cosine. It's also slope. Isn't slope change in y over change in x? That's the definition of tangent. It is the slope, okay? We're going to talk about that when I show you some cool interactive websites later. All right. This is what you have on your sheet. It does say you really, really, really need to know these, okay? Reference angle real fast. Reference angle has to be positive. The notation for reference angle, I'm kind of old school and I usually use this, but your book uses this. By that, what I mean is given 110 degrees for theta, so theta is going around this way 110 degrees. What is the reference angle? It is measured to the x-axis, never the y-axis, right? It is 70 degrees. I would write this is 70. Your book would write theta prime is 70 degrees. Why do we even care what symbol? We really don't. But what you need to know is that if I ask you the sine of 110, you're really going to find the sine of 70. Those are equivalent. Okay? It's a reference angle. In this quadrant down here, if I had instead of 110, I'd gone 7 pi over 5 or some crazy business in radians. So I'm down into this quadrant somewhere. Where do I draw my little triangle? Back up, right, to the x-axis, and I find this angle in here. Everybody okay? If it's degrees, we're all really good at it. If it's radians, we're all really stinky at it, right? Yep. Unless it's something easy like if you are going negative pi over 4, the reference angle is just pi over 4. Okay? That one we could do without too much pain in radians. But that's the worst bow tie ever, yes? Yeah. But does everybody know what I mean when I say your reference angle always makes one of these bow tie triangles, right? It's got to be to the x-axis, not the y-axis. All right. I think we went through most of this. The only thing I want to make sure you remember is that all students take calculus. Tells us what again? Yes, which functions are positive. And it only refers to sine, cosine. Did I spell that right? I was writing and talking at the same time. It only refers to the basic functions. Like if you ask me cosecant, that's not one of those letters, right? If I ask you where's the cosecant positive, you have to think, well, that's a reciprocal of sine, so it's in quadrant 2, that it would be positive. All right, I'm going to skip some of this. Quadrantal angles, do we know what that means? It means things like 90, 360, pi over 2, 3 pi over 2, pi. When they land right on the quadrant, they don't have a reference angle, okay? Don't have a reference angle. That's why you need those r over x, y over x definitions. Oh, this section just asks us to do a quick reference angle. You have to do this on one of the assignments. I don't know which one it is. But if you draw 330, please make sure you show me a directional arrow to show me that you went in a positive direction. 330, what's the reference angle? 30 degrees. Okay, so we went around 330 this way, and the reference angle is 30. Everybody good? I cannot stress enough, if I give you an angle in radians, the answer needs to be in radians, unless the whole question was convert to degrees. But for this, your reference angle needs to be in degrees, or radians. Try that again. Okay, 3 pi over 4. Pi over 4 is a 45, yes? You know that much? So we're going negative 3 45s. There's 2, 3 45s. Does that make sense? 1 45, 2 45s, 3 45s. Okay. So what is the reference angle in here? In degrees, it's 45. Can you give me that in radians? Is it okay to convert this to degrees and then do the whole thing and then at the end convert it back to radians? Absolutely. For number 3, put this one on here because it's weird in a couple ways. First of all, it's not reduced. It's good for me to, I want to teach you a little trick to convert quickly to degrees. Pi is the same as 180, yes? So if I think of that as a 180, 6 goes in there how many times? So then I have 9 30s, which is 270. So do you know how to draw a 270? Okay. Does it have a reference angle? No, it's quadrantal. I always feel like I don't pronounce that right. I don't know. I don't know how else you pronounce it. But. All right. I'm going to go to number 6 because I don't think we need this much practice. I just want to do one more that's radians with you. Here again, I would do a quick in my head conversion. Pi is 180. 180 divided by 9 would be what? 20. So negative 5 20s would be negative 100. So to draw it, it's going this way just past the 90. The reference angle then, in degrees, would be what? If it was 100, it would be 80. Okay, to convert that back to radians, if we do a quick times pi over 180, these would cancel. We'd have 8/18 or 4/9. Or somebody could have been able to do pi minus 5 pi over 9 in their head. Those fraction freaks. Okay? Sam's brother was one of those fraction freaks. Are you a fraction freak, Sam? Good at fractions? Your brother too. I was thinking of that, Sam, but you're absolutely right. Both of your brothers were good at fractions. All right. I'm not going to do the example on this. I'm just going to jump right into this problem because we did this last semester at the very end. Little bit, go 2 to the right, down 5. This is an X and a Y, but it's also your opposite and adjacent if you're going to put your little angle in here. How do you find your R then? 2 squared plus negative 5 squared equals R squared. We get, this is a question they gave us right here. It is a okay, wait a minute. It is a distance of 5, yes. But it's easier for me if I put it on the picture as a negative, because at the end of the problem, everything that used that coordinate is going to have to be negative. In this quadrant, the only thing that's going to be positive is cosine. If I put it on, I'm less likely to forget to go back and check them at the end. That's my thinking anyway. All right, I do Pythagorean theorem, I get square root of 29. Is everybody all right? All right, so quickly, sine is y over r, or square, or opposite over hypotenuse, so negative 5 over square root of 29. I always write it down without rationalizing it the first time, and then I rationalize it because you do have to rationalize it, but it's easier to flip over for cosecant, isn't it, if I flip this one? Square root of 29 over negative 5. Okay, go back and rationalize it, multiply by square root of 29 over square root of 29, and it becomes what? Negative 5 square roots of 29 over 29. Isn't that lovely? Michaela, I saw you on TV this morning. Basketball. This is basketball, bro. All right, cosine. Now what? You're a basketball pro, or you are on TV breaking your leg? Yes. Cosine is 2 over square root of 29, which would rationalize as what? 2 square roots of 29 over 29, and make the secant just square root of 29 over 2. Am I going way too fast? Fail? Tangent is the easy peasy one because tangent is just y over x, so we were given that without ever drawing anything, right? It's just negative 5 over 2. And cotangent then is, okay. If this is a test or quiz, at this point, take 1 second and remind yourself that in the fourth quadrant, all students take calculus means only the cosine should be positive. Everything else should be negative, yes? Got a negative there. Reciprocal had a negative. Cosine was positive, reciprocal is positive. Tangent and cotangent should both be negative. Double check your signs because it's so easy to get those wrong. I'm not going to do another one of these. I think you got this. Yep. I'm going to just really quickly talk about this one because if you went left 12 and up 4, when you do Pythagorean theorem, you get the square root of 160, which is 16 times 10, or 4 square roots of 10. So all of these are going to be divisible by 4. So you're going to have a big reducing party at some point, okay? And you could actually reduce them all by 4 here before you started putting them in sine, cosine, tangent if you wanted. All right, everybody okay? I don't think you need me to do 10 of those. All right, then we're going to look at quadrantal angles in the unit circle, but I'm actually just going to skip to the unit circle ones. No, I'm not. First, I'm going to talk about, Philip asked me this yesterday, okay? He came up and he asked, I learned to, instead of that silly finger thing, he said, I just learned to do the special right triangles. So he learned that if you had a 30, you just put on here x, 2x, and x square roots of 3 from the special right triangles. And so then sine is opposite over hypotenuse, or 1x over 2x, or 1/2. That was sine, and I just put it in the front. It's in the back. Cosine is adjacent over hypotenuse, or square root of 3 over 2. Okay? So I want us to practice because if you get confused, and I'm telling you can't use your unit circle and you're not sure you've remembered it, can everybody draw 30, 60, 90? Maybe. And the other reason is it's on the ACT, guys. It's on the ACT so many times. And it isn't necessarily just ask about a 45, 45, 90, but if they tell you this is a square with sides of 7, that's a 45, 45, 90, right? So you should be able to do, well, its diagonal is 7 square roots of 2, like that. Go on to the next problem. If you know those special triangles, it will help you so much on the ACT. All right, not because it's going to ask 6 questions about special right triangles, but because a lot of the answers, if you knew your special right triangles, you could go through the problem much faster. All right, before I talk about these 2 questions, I want to tell you where those come from. This is my super duper mini lesson on how do you know these patterns. Because I hate that some teachers don't ever teach you this. If this is equilateral, all these are 60. Guys, pay attention. This is equilateral, all these are 60. If I drop that guy down, what's he cut it in half up here and get? This is... Now, did I just cut this segment in half? Okay, so I'm going to call this half x. That would make this half x, which would make this whole side. Now, if I do Pythagorean theorem, this leg down here squared plus this mystery leg squared has to equal the hypotenuse squared. I'm talking about this triangle over here, yes? Okay, what's 2x times 2x? If I subtract an x squared off each side, what do I get? Please don't tell me 4. I get 3x squared, yes?
Oh, I get it.
I square, yeah, you just take off the x squared, right?
Yeah.
No.
Do it.
So this is square root of 3, but the square root of x squared is just x. So this length across from the 60 is x times the square root of 3. That's where that comes from. Got it? Okay, one more super easy one. What do you know about this triangle if it's 45, 45, 90? These are the same. We have x, x, and I need this. Leg squared plus leg squared equals hypotenuse squared. X square root of 2. We good? That's where those come from. All right, here we go. We're going to practice with 3 problems, and then we're going to use our unit circle. Can you do 3? You can do 3. Come on. Let's do 3. 5 pi over 3. My brain thinks in degrees. Pi is 180. 180 divided by 3 is 60. 5 60s would be? 5 times 60 would be 300. What's left here then? 60. Okay, short leg is x, hypotenuse is 2x, long leg is x square roots of 3. What am I going to forget if I don't do it right now? Yes, there is a negative here because I went down. I went to the right and down. Now, could I replace all those x's with 1? Sure. But I'm just going to leave them because the sign is y over r, or opposite over hypotenuse. The x's cancel and I get what? Okay. Number 10. 210. Reference angle, anybody? Okay. That makes this one 60. Okay, I'm going to put my cursor over something and I want to know what I should write right there. Nope. Across from 60 should be what? X squared roots of 3. It went to the left, so it should be negative. Okay, what about this guy? This is the short leg. He's across from the 30, so he should just be x, and it should be negative. Yes, good job. This is 2x, and it's a hypotenuse. The hypotenuse is always positive. All right, cosecant is hypotenuse over what? Opposite. So hypotenuse is 2x over opposite, which is negative x, so that is negative 2. Reference angle for negative 315. Anybody? 45. So where's the square root of 3 go? Okay, x, and x square roots of 2. So cosine is adjacent over hypotenuse, or x over x square root of 2, which would be 1 over the square root of 2, or square root of 2 over 2. Most of us are really good at those 45s, right? Everything square root of 2 over 2, cosine and sine. Okay. All right. We're going to use our unit circle to do the rest. Everybody knows on the unit circle that the first coordinate is the cosine and the second coordinate is the sine, yes? Cosine, sine, x, y. Tangent is sine over cosine or y over x. Okay, here's my example. If I go to 5 pi over 3, yeah, you're good. If I go to 5 pi over 3, you could always use Faisal's table too, but it's taller. I hope he comes back. All right, sine, tangent. We're supposed to do tangent. So we have y over x. So we have this mess over this mess, which means this divided by this, which means what? Divided means times the reciprocal. I'm explaining this once, and then we're all going to make fun of you when you ask later, okay? Every time you do this with numbers off the unit circle, what's going to happen to these 2's? So when we say put the y over the x, we can just do the top of the y over the top of the x and be done, right? So later on when we do this magic and you go, what happened to the 2's? We're all going to go, she explained that already. Okay.
That's a really weird circle. What is it?
Unit circle, guys. Everybody got it out? Here we go. All right, find 7 pi over 6. What quadrant is it in? 7 pi over 6. Find it, find it, find it. 7 pi over 6. Cosine is the... Seven pi over 6, cosine is x, so it's negative square root of 3 over 2. I'm really frightened.
Where did the 2 go?
It's right there in the answer. It only disappears when you do tangent and cotangent.
But should you have a negative 1 down there?
Okay, secant of negative 3 pi over 4. Most of you have trouble when they're negatives figuring out where you're at. If you just look positive and you go, okay, 3 pi over 4 went that way, that far, and I got to go that same way this far, puts me down here. All right, now be careful. Secant is the flip of cosine. When I flip that mess over... Yeah, if I practice this, here's another one you should just memorize, and we can make fun of you when you can't remember how to do it. Just kidding. This would become negative 2 square roots of 2 over square root of 4, which is 2, which will reduce to what? Negative square root of 2. So anytime you flip over square root of 2 over 2, you just get square root of 2. Yeah, this one was negative. All right, tangent at pi over 2. Go to pi over 2, the ordered pair is 0, 1. Tangent is y over x, so I get 1 over 0. You leave that answer on your paper, I guarantee Hofbauer will mark it wrong. Okay? You either write 0 or undefined, or if you want it wrong for sure, you write 1 or negative 1, because that's what I get sometimes. This one is, which one? Undefined, okay? It says up here, if it's undefined, write undefined. What that means is, do not write this symbol, because I will count it wrong. No. Some people write 0. It means no solution. Or empty set. You can write undefined or UND. 4 pi over 3. 4 pi over 3 is down here. Cotangent. Reciprocal of tangent. So it's going to be x over y. I lost the 2's. Negative divided by a negative is going to become positive. When I rationalize it, I'll get what?
Root of 3.
Whole bunch of you got it wrong. 1 over the square root of 3, we multiply by square root of 3 over square root of 3, we get square root of 3 over 3. Cosecant at negative 5, shh, guys. 5 pi over 4 is 225 this way, we're going this way, so it's got to go all the way to here. Cosecant is the flip of which one? Sine, so it's positive. But what did we just memorize a minute ago? When you flip that over, you just get square root of 2. And this should be the easiest thing ever. Cosine is x. What's the x value?
Over 0.
No, it's cosine. You don't put over anything. It's just the x.
So it's 0. So 0 over negative 1?
Cotangent at 270. Down here, cotangent is what?
Is it?
It's x over y, which is 0. Sine at 90. Up here at 90, the sine is just the y value, so I write 1. Negative 60 is down here. The tangent is y over x, which is?
Negative square root of 3.
Thank you.
Welcome.
Everybody got that? Okay, put down your pencil and look up here.
Put it down.
Oh, did I close what I was? All right, I lied. Seriously, what just happened? Okay, guys, please listen. Watch. This is a really, really fast review of some things. So that means amplitude is the height, yes? Above and below the midline, okay? Period is inside on the x, so it is the opposite of what it seems. When you increase that number, the period is actually shorter. Okay, increase the period, it takes longer to finish. This is everybody's least favorite, right? This is where you gotta like do 3/8 pi and 7/8 pi and ugh. Okay? Shh, guys. If you recall, we are recording. It would be really appreciated if we were on task. Okay. This graph, I'm going to go through this really quickly because I want to get to a couple examples. But what I want you to do, quick poll, how many of you have only had Honors Algebra 2 for your trig experience? You did not take trigonometry at any time. Okay. So I want to review this because your teacher probably didn't do this with you very well last year when you had Honors Algebra 2, but or you didn't catch it because it was your first experience. The sine graph is the red one, yes? Okay. Watch what it's actually related to over here. It is the height. Sine is the y value, yes? Okay, look what's happening on my little triangles I go around. The y, that red line, is getting longer and longer and longer and longer until it reaches its maximum. Okay? Then it starts getting shorter and shorter and shorter. Now it is a y value, so once it reaches nothing or its minimum, it's not actually minimum because it's a y value, so when I go down here it becomes negative, yes? But it's getting more and more and more negative until it reaches its minimum here, actually. And then it's a y value, so it's still negative, but it is getting shorter and shorter and shorter back to 0. All right? Does that help you understand where that comes from is related to the unit circle? If you had trigonometry, you did a little spaghetti thing where you break pieces of spaghetti, maybe. If Miss Oster had time to do that activity, I don't know. Okay? The cosine, watch this time, guys. The cosine starts at its maximum. Look right here. Cosine is this dark blue. Do you see here? Watch it get shorter. Now do you see it getting shorter? On the triangle that I'm forming. As that gets shorter and shorter till it is nothing. Okay, so it started as long as it could go and it got down to 0. Now it is x value. So on the left side, the x value is negative. So now I'm already negative, but it's getting more and more and more negative until it's at its minimum. Then it is still negative, but it's getting shorter and shorter and shorter until it disappears back to 0. And then it's getting longer and longer until it's at its maximum x value of 1 again. All right, we're going to talk more about tangent later, but tangent is the slope. Look at this. Do you see where my cursor is pointing to the hypotenuse in that triangle? That is a low slope. It's not a very steep slope. Yes, if I had to climb up that triangle, I could probably make it. All right, the slope is the tangent. The tangent increases to 1 when you get to 45. When you go past, it can get infinitely large. This can get infinitely steep until you get up to here. And then what kind of a slope does a vertical line have? Undefined, okay? Then as you go over here, the slope is now negative but very steep, and so on, okay? We'll talk more about tangent later. All right, I want to switch over and talk about this worksheet. We just want to plot a few things on here and talk about even and odd. Sine graph is related to y value. As we go around, the y value increases. It starts here and it's getting taller and taller and taller. If I took those little pieces of spaghetti and moved them over here, I'd get this. Okay, that's what I was talking about, the spaghetti thing. All right, as you moved into this quadrant, they'd still be positive, but they're getting shorter. See how that would go? All right, what do you know? Well, if this is a unit circle, the radius is 1, so the furthest we ever get away up and down is 1 to -1. Does that sound familiar? All the way around the unit circle is radians is 2 pi, so 1 complete cycle takes us to 2 pi. Halfway there is pi, pi over 2, 3 pi over 2. When you do a graph on your homework or for a test or for a quiz for Miss Hoffbauer in pre-calculus, you must list 5 ordered pairs for one period. You can't say it goes through 0, 0, pi, 2 pi, 3 pi, 4 pi. You have to tell me in the first period what are 5 places it goes through. Can you do that for me? Anybody? 0, 0. What's this one? Pi 0. Whoops. Pi comma 0. I don't know what that says. 3 pi over 2 negative 1. And 2 pi 0. All right. Domain and range. I drew 0 to 2 pi as the domain. But the actual y equals sine x keeps going, right? So therefore, the domain is infinity, and the range is negative 1 to 1 inclusive, unless there's an amplitude change, right? The even or oddness of a function refers to whether it is y-axis symmetric, remember that from last semester, or origin symmetry. All right, if I draw this through the origin, it actually goes like this. So that is what? Origin symmetry or odd. That was a really bad little graph up there. All right. Somehow I did manage to save it with the ink last period. Okay, Hoffbauer, not clear page, clear ink. Got it. The difference when we're doing cosine is it's the x over to here. So the x is getting shorter and shorter. It starts at its maximum. Okay, this should not look like this. That's not a cosine graph, okay? It should actually be a quarter circle, quarter circle, quarter circle, and a quarter circle. I didn't do a very good job, but you get the idea? Maximum, minimum of 1 and negative 1, and the period is still what? 2 pi. So someone tell me those 5 ordered pairs really fast. 0, 1. What's another one? Pi over 2, 0. Pi negative 1. 3 pi over 2, 0. And 2 pi 1. Domain and range any different? No. Even or odd? Again, if you drew it both sides, it would look like this. What's going on right there? Y-axis symmetry, right? Do you see that it's going to do the same thing on the other side? Y-axis symmetry is even. All right, that's all the time I'm going to spend on that worksheet today. We're going to come back and talk more about tangent. I would like you to go to the other worksheet. We're going to do 2 quick examples if we can get through them on the back side of worksheet 5. Tomorrow, I promise, I'm going to go much more slowly and in depth explaining this. But because I know some of you would like to get started on this graphing assignment tonight, I'm just going to do 2 easy graphs, okay? Because you've seen this before, I'm going to pretend you remember how to do it. Okay, the number in front is called the amplitude. This is on the back of worksheet 5, I believe, yes? 6, thank you, it's 6. Yeah, I'm sorry. All right, so 6B, did you find it? All right, so the amplitude, or A, is out here in front. And on this one, the amplitude is 2. That means all the maxes and mins are going to be where? Between positive 2 and negative 2. You like that y-axis? That was nice and straight, wasn't it? What did I just do? Okay. The only other thing besides a regular cosine is that this is really saying 2 cosine 1/4 theta. They just wrote it as theta over 4. So our b value is 1/4. Remember, it's the reciprocal of what it seems like it does. 1/4 doesn't make it smaller. It's the reciprocal idea. It's going to stretch that period out 4 times as long. The rule is you take the normal period of 2 pi and you divide by that b value. Do you remember that from last year? So 2 pi divided by 1/4 actually becomes 8 pi. So this is going to finish one cycle by 8 pi. Now, I don't know how you like to do these. I like to just draw it and then go back and put in the labels. So it is a cosine graph, meaning it starts at its max. We all love max. Starts at max. Okay. And it finishes by what? What is this x value out here? 8 pi. Divide that in half and you get 4 pi. Divide that in half again and you get 2 pi. My graph is really scrunched up and badly drawn. Okay. Can I go on and do another problem rather than put in the 5 ordered pairs? You guys can figure out what the 5 ordered pairs are since we have everything labeled? Okay. Let's do a quick example of number 12. Okay. Let's do number 12. Let's talk about 2 things that are new on this problem. This added or subtracted number without any parentheses in the problem means that it is a vertical shift. These are actually easier than they seem. Vertical shift of up 1, just going to change the max and mins, right? It's not going to change all those pi over whatevers. This one actually has a period of what? There's nothing here, so period is just 2 pi. What's the amplitude, though? Amplitude is positive 3. What is the negative doing? Yeah, it's reflected. In this case, the sign normally starts at the midline and does this. Ours is going to start at the midline and go down first. Does that sound familiar? All right, I know I'm going really fast. I'm going to go much slower tomorrow through these, but somebody's going to want to start their homework tonight. Vertical shift of up 1. Where are the maxes at? Yes, I know he left the room, but where are the maximum values at? Yes, 3 units above that, which would be up here at 4. I like to draw little dotted lines for myself so I don't go out of my area. What's 3 units below 1? -2. All right, and we said this one starts where? At the midline and goes down. Okay, now that means this spot on the x-axis where it finished is 2 pi. This is not 2 pi. No, its x value is 2 pi. I lied. Okay, its y value, though, is what? 2 pi 1. Halfway there would be? No, halfway to 2 pi would be pi. I started to write what you said. This would be pi over 2. Okay, this is what I meant, what I was talking about, trying to say a minute ago. Okay, this is not, like over here is not pi over 2. Where it hit its min is pi over 2, okay? All right, is that what's halfway to that? 3 pi over 2, which would be up here at 3 pi over 2, 4. And this one would be 0, 1. Okay, did I get my 5 points labeled? All right, we did much better than all the other classes at finishing a couple examples today.